Hi guys, we are still in water quality related problem in irrigated agriculture. As I told you that we have 4 points related to water quality. The first is salinity, water infiltration rate, specific ion toxicity, and miscellaneous problem. Salinity has some symptoms like wilting or dark color on leaves and so on. Water infiltration problem. I told we have a relatively high sodium and low calcium content of soil, or water reduces the rate at which irrigation water enters soil to such an extent that sufficient water cannot be infiltrated to supply the crop on irrigation. I told you that the high sodium concentration led to a low infiltration rate, while the high salinity caused an increase in infiltration rate. So when you are talking about infiltration rate, you have to put in your consideration salinity and sodium concentration. Sodium concentration with respect to calcium and magnesium. And there is a parameter called SAR, which equal to the concentration of sodium over the root of calcium plus magnesium over 2. There is an equation. I will explain the equation for you. I think I discussed salinity and water infiltration rate, toxicity, 3 parameters included in FAO to explain toxicity, water toxicity. These 3 parameters are sodium, chloride, and boron. Although boron is considered a trace micronutrient, however, the high concentration of boron caused plant toxicity. Although toxicity problem may occur even when these ions are in low concentration, toxicity often complicates a salinity or water infiltration problem. Damage results when potentially toxic ions are absorbed in a significant amount with the water taken up by the root. The absorbed ions are transported to the leaves where they accumulate during transpiration. The ions accumulate to the greatest extent in the area where the water loss is greatest, usually the leaf tips and the leaf edges. Okay? The last point which the FAO have been taken in consideration is miscellaneous problem or different problem, such as nitrate, bicarbonate, abnormal pH, and sometimes some scientists take, for example, heavy metal like cadmium if you are going to evaluate wastewater for irrigation or treated wastewater for irrigation. Let us now discuss a very important table prepared by FAO to summarize the previous 4 points for salinity for the problem discussed. This is the FAO table, a guideline for interpretation of water quality for irrigation. Actually, this table is very important when you are going to evaluate the water for irrigation. As you see, the table includes potential irrigation water problem here for the parameter used for water evaluation. As I told you and discussed together we have 4 points. The first is salinity, the second is infiltration rate, the third is specific ion toxicity, the third is specific ion toxicity. The last one is miscellaneous problem or miscellaneous effect. So here the FAO concluded a range of each parameters demonstrating the level for the safe level of each concentration and the concentration which let the water be at risk or there is a restriction in use. The first parameter is salinity. Salinity is represented as electrical conductivity and has a unit of DC Siemens per meter. And if you have electrical conductivity with the water less than 0.7, then non degree of restriction on use. If the EC between 0.7 to 3 DC Siemens per meter, then you have slight to moderate degree of restriction in use. If your water is more than 3 DC Siemens per meter, then you have severe degree of restriction in use. If you would like to convert the electrical conductivity from electrical conductivity to concentration of salt, then you have to convert the electrical conductivity into concentration of salt by multiplying 0.7 times 640. If you multiply these on 640, you will get 448, which approximately equal to 450 milligram. Then you will get the concentration on milligram per liter. If you have the concentration TDS, total dissolved solid, if you multiply the electrical conductivity in DC Siemens per meter on 640, then you get the total dissolved salt in the water in the unit of milligram per liter, and consequently if you have the concentration of salt less than 450, then you will have no degree of restriction in use. 450 to 2000, you will have slight to moderate degree of restriction in use. If you have more than 3 decisiemens per meter, then you have severe degree on restriction in use. Okay.